Hi everyone. In this video, we will understand the multi-quadrant operation of an electrical drive, which is imperative to understand because in electric vehicle we require the forward operation, we require the reverse operation, as well as we also need a regenerative braking. So therefore, to have the regenerative braking and to control my electric vehicle in forward and the reverse direction, we need to understand the multi-quadrant operation of an electrical drive. So let's start. Any electrical drive which comprise either AC motor or the DC motor can operate in the four quadrants, and these four quadrants are forward motoring, which has the uh, this forward motoring which has my speed and the torque in the same direction, and the forward braking. These two we can easily understand with the by taking an example of an EV where my EV is running in the forward direction. So my motor which is being deployed in the EV is working in the motoring action, and if I have to apply some braking uh, action over there, so in which quadrant it is working? It is working in my second quadrant. Similarly, if we have to move an EV in the reverse direction, so that is nothing but the reverse motoring mode. And if we have some kind of a braking system in the reverse direction, then it will have the fourth quadrant operation, which is the reverse braking. And the regenerative braking also works among these four quadrant. The regenerative braking also happens, and which we will understand by taking one example. So let's understand the multi-quadrant operation of any motor, whether it is AC or DC, by using one hoist load example. And to do so, I'm having these four quadrant dividing on the speed, the angular speed I'm taking here on the vertical axis, and I'm taking the torque on the horizontal axis. So the first quadrant and the second and fourth quadrant, let's understand all these four quadrants now. Before starting with the quadrant operation, we know that this relation, that power is equals to my torque and the angular speed multiplication, which is getting converted from electrical to mechanical energy, and the motor action happens. So in the first quadrant, let's say that my the motor rotor is rotating in this, let's say, the anti-clockwise, and this speed direction, as of now I'm taking the positive, so this is my positive speed direction, and the torque being produced by my motor is also in the same direction. So these two both are in the same direction, so therefore my power also becomes the positive over here. So therefore this is the first quadrant operation, whereas in the second quadrant my motor is running still in the same direction, which is again the anti-clockwise. However, the torque which is required by the motor or required to produce to fulfill the load is in the reverse direction. So therefore this second quadrant, where the speed is still remains same, but the torque direction gets changed, therefore my power is also gets negative, and this is nothing but my forward braking mode. In the third quadrant, we can see that easily my motor direction has changed now. The motor direction now, it is running in the clockwise direction over here. So therefore the motor directions gets changed, as well as the torque being produced by the motor is also in the same direction. So that's why the power remains positive, and this is nothing but my reverse motoring. Here the both the speed as well as the torque, the direction of my motor is also changed, and the torque being produced by the motor is also changed. So we can easily interpret this with that my vehicle is going in the reverse direction. And the last quadrant, which is the fourth quadrant, we can see that the speed is still in the reverse direction. However, the torque being produced by motor or required by the load is in the reverse direction, opposite to my speed. So therefore this quadrant is nothing but my reverse motoring, reverse braking, because we can understand that still EV is going in the reverse direction, but the torque being produced by the motor should be opposite to my the direction of my motion. So therefore, this is nothing but the reverse braking. So let's again simplify the all the four quadrant operation over here. So here we have the hoist load, and this is the weight which we need to, for the first quadrant, this is the weight which we need to pull in the up direction. So the weight should go in the up direction, which shows by here as an arrow, and this is nothing but my counterweight. So this is nothing but my counterweight. So this counterweight is such that if my hoist is full or having the full load capacity over here, then this counterweight is less than my the full capacity of my hoist. So therefore, this weight, which is the counterweight, is will be less than my this full loaded hoist. Now here we need to pull this hoist in the up direction, whereas the gravitational force is working on my counterweight in the downward direction. So to pull this in the up direction, this is one thing which is clear, that the motor speed is going into the anti-clockwise direction, which is I'm taking positive, because I need to pull this up. So here I need to pull this up. The counterweight is also working in the same direction, which is going upward due to the gravitational force over here. However, the counterweight is less than the full loaded hoist. So therefore, the motor has to produce a torque in the same direction where my rotor is also moving, which is the anti-clockwise. So therefore, both are the positive, and this is nothing but my first quadrant. Coming into the second quadrant, so this is my second quadrant. Now assume that I need to pull empty hoist chamber over in upward direction, and as we know that this is the counterweight is now more than my the empty hoist. So therefore, uh, the direction of my motor is still in the anti-clockwise, because I need to pull this up. However, this counterweight is going downwards because of the gravitational force. Then this force is more than the force which is required to pull this empty hoist in the upward direction. So therefore, motor, to keep the motion in the upward direction and to manage that this should not be unstable because of the gravitational force is working in the downward direction, motor has to produce a torque which is opposite to my direction of my rotor. So this motor is need to produce a torque which is in the clockwise direction. So this is nothing but, again, the hoist is going in the upward direction, but the motor has to produce the torque which is in the reverse direction. So therefore, a braking is happening over here, which is known as the forward braking, which is the second quadrant operation. In the third quadrant operation over here, now let's assume that I need to pull down the empty hoist over here. So I need to take this down, whereas my counterweight has to pull up upward direction, because of both these two are attached with the same pulley. So therefore, this has to go up, the counterweight has to go up, and the empty weight has to go down. So to do so, the direction of my rotor is going to be the change now. Now it will be the clockwise direction, and motor has to produce the torque in the same direction because the counterweight is more than my empty weight. So therefore, I need to pull this counterweight up. So therefore, the motor has to produce a torque which is in the same direction. So this is nothing but the all the direction and the torque is in the same direction, but the direction has changed with respect to the first quadrant. So therefore, this is nothing but the reverse motoring. So this is nothing but the reverse motoring. In the fourth quadrant, now let's assume that a fully loaded cage has to be dropped down. This cage has to be dropped down. Counterweight is need to be pulled up, and as we know that now the fully loaded cage has more weight than the counterweight. So therefore, the gravitational force will work more on the fully loaded cage, and I need to control the speed. The direction of my motor will remain in the same direction, which is the clockwise direction, because I need to take this cage down, fully loaded cage down. However, to control the speed, because now if I don't have the control, this cage will drop freely due to the gravitational force. So to control the speed, motor has to produce a torque which is reverse to the direction. So motor has to produce a torque which is in the clockwise direction. So this is nothing but my reverse braking. So let's summarize the electric machine working mode, whether it is working as a motor or generator in all four quadrant operations. So in the first quadrant, electric machine, or my machine, which is whether it is AC or DC, operating as a motor, because both the speed and the torque in the same direction. Whereas in the second quadrant, the machine receives the mechanical energy, converting into electrical energy, returning back to the electric source, because the braking is happening. Therefore, the machine is working as a generator in the second quadrant. And this is also, we can relate with the regenerative braking in case of the EV. If I'm moving my EV in the forward direction and I have to apply a brake, so that time my motor should take this mechanical energy which is being generated while going by EV in the forward direction and applying the brakes over there. So that mechanical energy is being converted again into the electrical energy, and which is fetched back to my battery storage systems. So therefore, the regenerative braking actions happen in the second quadrant. Of course, it all is being done through my converters, power electronic converters. And the third quadrant, again, the torque and the speed is going in the reverse direction. So this is again, my motor is working as a, my machine is working as a motor, but in the reverse direction. And in the fourth quadrant, again, let's understand that my vehicle is going in the reverse direction, but I have to apply a brake over there. So again, the mechanical energy is being converted into the electrical energy in the reverse direction also. And now my machine working as a generator, and the power is being generated by the machine can give back to my battery storage through my converters. So let's quickly summarize the direction and the torque for all the four quadrants. So we have seen that in the forward direction, the speed is positive, the torque is also positive, my power output is also positive. So this is my motoring action. In the second quadrant, forward braking, speed is still, or the direction is in the same direction in the forward, and the torque is getting opposite to my speed, and therefore the power is also negative. And a negative here, we can easily see that if the power output is plus, then my machine working as a motor, and if the power output is negative, then my machine working as a generator. So in this reason, regenerative braking can happen. So here also regeneration can happen. And in this third quadrant, both direction of my rotor and the torque being produced by the motor is being changed, and therefore the power output again remains positive. So this is again my motor action. Taking the applications, so we can have these applications such like compressor, pump, and fan type loads, which require only operation in the first quadrant, which is nothing but the operating the forward motion. There is no braking also required. So all these simple kind of applications being run in the first quadrant. Whereas we are we are talking continuously about the EV, which is nothing but the transportation system. So which requires the operation in the both direction, forward and the reverse. And we also need to get the regeneration from here. So therefore, for the EV application, we need all the four quadrant operation. And this is again managed by that if not operation is restricted to quadrant first and third, the dynamic braking or mechanical braking may be required. So if we are not including I mean, let's say the quadrant first and the third, where uh, we are only strictly the quadrant first and third in case of the EV, where I'm only getting the forward motoring and the reverse motoring, and we are not having the reverse braking or the forward braking. So therefore, I can say that by applying the mechanical brakes, I can lose those energy, which is not creating my regeneration. So EV can work in the fourth quadrant, but if I'm only sticking to the first and the third, then the regeneration will not take place. So I hope we have understand that how an electrical drive works in the fourth quadrant operation, and how we can correlate with the this with an electric vehicle application along with the regeneration. Thank you.